In the earlier class, we defined the conics, right? So the locus of point, or locus of point for a conics, locus, not locus of point. Locus is a set of points which satisfy a condition. We define the locus for a conics. Am I right? So you remember what are the thing we had for a conics? Oops. What is we had for the conics? We had two quantities, two important quantities. What is that? One is the directrices line. Let us call it as D. Another one is a focus, let us say a focus S, right? And all the thing what we had is the set of point P. Let me take the point P, which should satisfy condition. So it should satisfy. So let me draw. This is the distance. Sorry, it is not okay. Fine. So this is a distance. Let me call it as M, and this is a PS. Okay. What we had is if PS by PM equal to a constant, we call that as a conic, right? And we term that as a constant as E, which is eccentricity. Okay. And then we define, depending upon the E, whether E is equal to 1, less than 1 or greater than 1, we get the different conic curves. That's what your ellipse, parabola, hyperbola, all those things we will get. So first thing we will see, when E is equal to 1. When E equal to 1, what do you get is a parabola. Parabola is what? When the cone, when your plane is parallel to the tangent, means tangent of the cone. You got it? That's a generator line. Okay, so then what the curve you are going to get, that's a parabola. So E is equal to 1 is a parabola. Okay, so let us write. So when E equal to 1, what we have, this you remember this relation is called as what happened? Your PS equal to EPM. Sorry. EPM. Am I right? You remember what is this property? This is a focus.
Focus directrix property.
Correct, directrix. Directrix property. Oops. Okay, anyway, property. Okay. That is property. So now, when for a parabola E is equal to 1, then what will be a focus directrix property? Tell me at the time.
Parabola.
For a parabola, yeah, I am going parabola. When E is equal to 1, your focused property is going to be PS is equal to PM. What it says is, so the all set of points for which your PS is equal to PM, and that's what is going to be your, that all the points are going to satisfy this condition, and that curve is going to be your parabola. So how we are going to construct that equation of that parabola? Let us see. So first what am I going to do? I am going to draw a line perpendicular to directrix D and passing through S. Yes, exactly. That's axis. So let me call this region as, so let me use the same term what they have used in your book so that you won't confuse. Let this be Z. Now, let me bisect ZS. That means what? Let me take a midpoint and call it as O. In case of a parabola, will the O lie on the parabola? Why not? What is the condition of parabola? So let me call this is a point. Will the point O lie on the parabola? What parabola says? PS equal to PM. PS equal to PM. So this point OS is equal to OM.
It's bisected, right?
It's bisect, na? So these two are equal. So of course this point should also lie on the parabola. Am I right? So then I will always, my parabola goes like this. Something like this.
Okay.
Am I right? So all these points, they both will be equal. These points, they both will be equal. So therefore, when I bisect this, this point is also going to lie on the parabola. Okay. So before that, I should have given a definition of the parabola. I forgot to tell the definition of parabola. So what is the definition of parabola? When E is equal to 1, right? So what it says is, A parabola is the locus of the point in a plane which is equidistant from a fixed point and a fixed line. They both are equal, correct? When it's equidistant from a fixed point and a fixed line, that's what all your parabola is, right? Right. The fixed point is called as your focus and the fixed line is called a directrix. Okay, that directrix, that's what they given here. Fine, so this is what, so now we are going to construct the equation of the parabola. So we got all this idea, right? So basically what happened, this is the directrix, this is the focus. So this is the point, these two has to be equal. Always, for all the point, this segment and this segment has to be equal. So when I draw the axis and bisect this region Z as it O, then obviously O also has to fall on the parabola because they both are equal. Correct? So now when I construct this, I can do some jugglery. What am I going to do? I am going to draw a line parallel to my directrix and passing through O. So what is I am going to do? Okay. So then I am going to, what will I do? Then I have to basically find the equation, right? If you want to find the equation, basic equation what? Equation on x and y. That means you need a coordinate system. A point. We have not defined any coordinate system till now. We are just speaking about line and a point, right? So I have to define an origin and then I have to write lines, right? So what am I going to do? This I am going to define as an origin and this I will call as my y-axis and this I will call as my x-axis. Okay. So now if this distance, say something like A, so can you tell me what will be this point?
So A comma 0.
Fantastic, very good. So because x is A, right? So this is going to be A comma 0. Can you tell me what be Z?
Minus A comma 0.
Perfect, minus A comma 0. Okay. So now, so let this point be, this is the point we are going to find the equation. So to find the equation, what you write, we will call it as x comma y. You have to get the equation. Okay. Can you tell me what this point is going to be?
Minus x comma minus y.
Are you sure?
No, wait. The height.
What will be the x-axis? What will be x coordinate for this?
X will be
What will be the, okay, tell me what is the equation of this directrix?
X will be minus A.
Yeah, right. What is the equation of this directrix? Tell me. X is equal to minus A. Or you can say x plus A equal to 0. Correct? So of course, this point, what will be the x? Tell me.
Minus A.
Correct. Minus A and y will be the same y. Am I right? So then what we have, so these are all the points we have. So M, the point M is minus A comma y. S, point S is A comma 0 and point Z equal to minus A comma 0. Okay.
P.
Where we have, yeah, we'll write P. P is equal to x comma y and this is a locus. We want to find out the locus of this point P which is going to move all along there. Okay. And of course, O is 0 comma 0. Fine. So, and the equation of directrix. Is going to be what? X is equal to minus A or x plus A equal to 0. Fine. So now we got all the things. Now the parabola, what it says is this distance should be equal to this distance. Tell me what is SP or whatever SP or PS, whatever you call PS.
SP is equals to
2 points given. You know all the points, na? Tell me.
A minus Z x whole square.
A minus?
A minus x whole square.
Correct. A minus x whole square because this is a distance. Right? x1 minus x2 whole square plus y1 minus y2 whole square. That distance between 2 points. You already studied from your 10th standard onwards. Tell me what is this one?
Y square.
0 minus y, right? So that will be basically y square. Good. So this is plus y square. Now tell me what is the other point? PM.
X plus A whole square.
Yeah, x plus a whole square plus,
Only that much. Other will be y minus y.
correct, y minus y will be equal to 0, correct. And now the equation of the parabola says PS should be equal to PM, right? So otherwise you can take square also has to be equal, right? So it says A minus X whole square plus Y square will be equal to X plus A whole square. Let us open up. A minus X whole square is equal to A square plus X square minus 2AX plus Y square equal to X square plus A square
Plus 2a.
plus 2AX. Now x square cancels. When you take A square cancels. So what you get? Y square equal to, when you take this one here,
Equal to
4AX. And that's what your equation of your parabola. One important condition is A should be always greater than 1. Is that correct? Of course, A has to be greater than 1. We are taking the A here. Okay, so this one, when A has to be greater than 1. Fine. So that's why the origin will come here. I take minus A. So this is a Y square equal to 4AX and A is greater than 1. So this is the equation of a parabola.
Can A be like 0.5 or something?
Of course. Oh, sorry, what I said? Oh, sorry, 0. So, sorry. What I wrote, not 1, 0. Correct. Good. It is 0. Or this will be positive here. It can be 0.5 also. Because I said the origin, nah? We are taking it this side of the origin. So it has to be always positive. Okay. You got it? So this is what your equation of a parabola. So all you have to know is, so for the equation of a parabola, so in general what happened? So in general equation of a parabola is what? When you write y equal to 4, y square equal to 4ax. By seeing itself, you can say this a should be the coordinate of your focus. Am I right? So, and the next question they are given. Find the equation of the parabola with focus at, okay, they are given one problem. The focus is given. The focus is they given as 2, 0. And directrix is x plus 2 equal to 0. Simple.
So A equal to 2.
A equal to 2, because isn't it? Because directricity formula, x plus A equal to 0, x plus 2 equal to 0. This itself says A equal to 2. So therefore your equation of a parabola will be what? Y square equal to 4 into 2x. So y square equal to 8x. This is the equation of the parabola. So you have to get the problem. Okay. They give another equation also. Yeah, now this is slightly tricky. Tell me how this will be. Okay. So let us do this problem. Find the equation of the parabola with a focus. That's what our focus S. Focus S is minus 4, 0 and the equation of the directrix is x is equal to 4. Okay, so what you will see, this will be a left-handed parabola. Let us see what happened. So we are having a, let us go with the same thing. Let us have the focus that is equal to what? Minus 4, 0 and let me draw a line along it. And we have the directrix. Directrix will be
Right side.
oops, sorry, I made it exactly wrong. Okay, so let us have your focus is minus. Sorry, minus is here, na? Minus 4, 0. Okay, and that's your S is minus 4, 0, and your directrix is x equal to 4. That means somewhere else here. Am I right? So let us write down this. So this is your 4, 0. Okay, this is your directrix. So this is minus 4. So the midpoint will be the 0, 0. Am I right? And that's what your origin is. Whoa. Fine. The parabola will obviously passes through this like this. So this is your left-handed parabola. Correct? What it says is this distance should be equal to this distance. Okay, so let us call this as your point P, which is x comma y, and let this be, remember, M. Okay, so can you tell me the points? S is minus 4 comma 0, this is 4 comma 0, so this point is going to be 4 comma y. So now these two equations has to be equal. So as a parabola, what it says is PS square should be equal to PM square. Am I right? So what is PS square? Tell me. X plus 4 whole square plus y square should be equal to PM is what? X minus 4 whole square. That's it, right? So this will be what? X square plus 16 plus 8x plus y square equal to x square plus 16 minus 8x. Okay, so x square cancels, 16 cancels, therefore you take the 8x here, becomes minus 8x, therefore y square equal to minus 16x. Okay, so now this line, if you see here, when you take a square of it, it appears to be complex, right? You have a root of minus, so it won't happen. Because whenever it comes, because the sign of this depends upon what is the x you are going to have. Okay, and you remember here the origin, the parabola is going to be drawn on the negative x-axis. Am I right? So all x is going to be what? Negative. So of course this is not going to be complex. This will be still positive. You got it? You got it, nah? Because every point is this side. So all this point here is x is always negative. So since x is negative, this will be positive, so of course it won't be a complex. Okay, so this is the equation of the parabola. Got it? This is a left-handed parabola. This side. That was a right-handed parabola. This is a left-handed parabola. Okay.